Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 350 intersection of two arrays 2. We're told that we're given two integer arrays, nums1 and nums2, and we need to return an array of their intersection. Each element in the result must appear as many times as it shows in both arrays, and we may return the result in any order. So here we're given an example, nums1, 2, 2 and 1, and nums2 which contains 2 and 2. Well, we know that the intersection is 2 and 2 because they exist in both lists, so we return 2. Now, the intersection in this, what it means in this problem is kind of like a Venn diagram intersection. It's the numbers which exist in both lists. It's not an intersection as in an order of, like a linked list intersection question. So that's something that kind of tripped me up a bit. So when we're talking about intersection, we mean the numbers which exist in both lists. And we're given another example, 4 and 9 exist in both lists, so we return 4 and 9. And we're given some constraints. So the way we're going to solve this problem is by using a hash map. So we're going to loop through nums1, we'll do a single pass and put each of our numbers into a hash map, and we'll say, and that will basically give us the count, the number and its corresponding count, so how many times it comes across. And then we'll go through nums2 and we'll check if the number is in the counter, then we can add it to a result list, which we will return. But what if, for example, we've got the numbers like 2? Well, the count will be 2 and then 2. So let me kind of visualize it. It kind of look like 2, 2. The moment we find the first 2, we'll decrement the counter by 1. And then when we find the second 2, we'll decrement the counter by 1 again. And if we find another 2, but our counter is 0, then we know that although this 2 is in nums2, it's not in nums1. So we won't add it to our result list. So let's actually start coding stuff up. Let's set a result list to an empty list in Python, and let's set our count equal to a counter of nums1. So this will do all the hash mapping for us using the counter function in Python. So this is really helpful. Now what we can do now is we can say for every number in nums2, well, if, and what we can say is if the frequency of the current number in nums2 is greater than 0, then we can say, well, now we need to add this number, so we can say result.append and add our number to our result list. And of course, we want to also make sure that we decrement our counter now, or the frequency of the number that we're at. So we say count num minus equals 1, and that should be all our code. So now we can just return our result list. So let's run our code, and we pass the 2 sample test cases. Let's submit our code, and we pass all test cases. So in terms of time complexity, we're looking at our O of n time complexity. So the fetching the number from the counter, well, that's going to be a constant time complexity. But since we are doing a single loop, that's going to be O of n, and space complexity is going to be O of n, obviously worst case, or actually every case, because we're storing the entire, potentially we could be storing the entire list in our result list. So I hope this video made sense, guys, and I'll catch you in the next one.